Greetings, this is Eugene the Philosopher, the greatest living philosopher after the unfortunate passing of Quentin Robert de Nameland, who has been the greatest living philosopher before me. Let's talk about nonlinearities and time. And I really hope this is going to be a short video, but you know how it happens, right? So hopefully I will be able to tell you what is nonlinear system, what is nonlinearity, etc. And hopefully I would be able to show you what kind of relationship it would have with time and things like that. But before we talk about what a nonlinear system is, let's talk about what a system is in general. And well, it's a rather technical term, but well, okay, it's probably a bad idea, but I think I'll start from a digression right away. So there's a Russian thinker, I've mentioned him in one of my previous videos, at least in one of them, Sergei Pereslegin. So he has this idea, and I'm not sure if it's his idea or maybe he's stolen it from somebody else, but the idea is about the so-called, what he calls meta-objects. So he has his own classification of the types of objects, you might say, or types of meta-objects, as he calls them. So this classification includes, I think, five different elements, but I'm not sure. Well, at least I can think of five. I don't quite remember how much he gives, but let's settle with five so far. So the first one is an object, right? So these are meta-objects. The first type of a meta-object is just an object. So it's this traditional notion about something, you know, that you can sort of isolate in a box, roughly speaking, and you can do something to it and it would respond in a certain manner, right? But in itself, it's something mechanistic, you know, something simple that doesn't really have any complexities inside of it. Let's put it that way. Okay, so that's one meta-object, the most simple one probably, and which was already well known in the 17th century. Then what he introduces is another meta-object, which I wouldn't really focus on, but he talks about a pair. So those are like two entities which interact with each other in some, let's say, complex manner. But so as examples of pairs, Pereslegin gives like a pair of a student and a teacher, for example, right? So it's a system, not quite a system, but a meta-object, this pair, which sort of co-evolves in some complex manner. So we have here some much more complicated interactions and etc. I'm not really buying this classification, by the way, but I'm just giving you as it is, but I think in general it's pretty interesting. So that was the second meta-object, this pair, or you might say a pair of lovers or something like that. So it's not quite a system, you know, it's something different still. But the third meta-object is a system, right? And what is a system? Well, it's a bunch of elements. It's a pretty much traditional understanding of the word. A bunch of elements with a bunch of connections between them, right? So elements might interact with each other through those connections, and that's what a system is. And like in the 70s, roughly, or maybe even in the 80s, everything became a system. You know, it's just, this word has become so popular, and it's just everywhere right now. You can see definitions on Wikipedia like blah 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 is a system, blah blah blah, or something to that effect. But the point Pereslegin makes is that system is not really that prominent. Like there are some other meta objects which cannot be reduced to a system, or rather they're completely different in the first place. Well, I've already named two, but there's at least two more that he lists, and those are much more interesting, I think. And so the fourth meta-object that he lists is a medium. So what is a medium? Well, it's hard to give it a definition. Like, I can probably do that, but I wouldn't. I would just give you a couple of examples. Well, it's just like any sort of continuous medium that we know about, like water or air, like the atmosphere, etc. Things like that, or even like interplanetary space, you might call it a medium also, even though people say, well, it's a vacuum. Well, no, it's not a vacuum. Well, in some sense it is, because the density in terms of particles is low, but well, it's a whole different story again. See all those plasma astrophysics, plasma cosmology types of things. So, okay, well, what is the difference between a medium and a system, let's say? Well, a medium has certain specific properties, like a medium can sustain waves, for example, whereas a system cannot, because, well, a system it's sort of limited, you know, it has some boundary after all, because it has limited set of elements and limited sets of connections, whereas a medium is sort of like everywhere, etc., etc. So a wave is a phenomenon which exists in this sort of continuous thing, which is a medium, for example. So it's an interesting notion. And another interesting notion is the fifth meta-object, which is a sphere, or at least what Perslegin calls a sphere. So in his understanding, and it's all kind of vague, you know, it's not very technical, but, well, a sphere is basically a sphere, you know. Like if you think about the sun or earth or any other complex things like that, well, this is a sphere, and one of its most, and I'm kind of speaking esoterically here, and I don't really like that, but I kind of like this classification, so I gave it to. So one of the properties of a sphere is that it's almost impenetrable, right? It's almost unknowable in some super ultimate sense, because, well, we cannot penetrate the Earth. We don't know what is inside the Earth. Strictly speaking, in terms of volume, we've only been to the uppermost, like, well, let's say 12 kilometers, if you count that from the surface downwards. But, well, if you count that from the atmosphere, that would be like maybe 150 kilometers, right? That's how deep we know the Earth. But the Earth itself, in terms of radius, is like 6,500, right? Or 64 at least. So, you know, that's 12 versus 6,500. So that's about how well we know what the Earth is about. So we don't know the Earth, nor we know the sun, because, well, again, we only see like the photosphere, which is like maybe, I don't know, tens or hundreds of kilometers deep if you count the sunspots, which are like holes in the photosphere. Again, maybe several hundred kilometers deep. So yeah, and the sun's radius is like 700,000 kilometers. So that's even worse than in the case of Earth. Okay, so yeah, well, that's what the sphere is. It's something impenetrable, something unknowable, and something with its own agenda in some sense, you might say. Like, again, both the Earth and the sun, you might easily perceive them as living beings, and that's completely validated, I would say. Again, see my videos about Onion of Aliens, where I've discussed that, like how the sun might be perceived as a living being, etc. This idea of Rupert Sheldrake, etc. Okay, one of the properties of the sphere is that it has all those shells, which you might or may not penetrate, or etc., etc. But ultimately, you don't know what the hell it is. That's the point, basically. And so you cannot contain it, or you might contain it, but you'll never reach the ultimate core of it, you know. And damn, there was an, oh yeah, so he actually, Perslegin himself actually tried to utilize these concepts in terms of development of strategies for cities, for example. Like, you might perceive the city as a system, but his point is that this is not correct. You should at least perceive the city as a medium, because, well, it is a medium. It's a place where some other things move, etc., which isn't directly, at least, connected to these other things. I mean, people, cars, like goods, money, etc., etc. But at the same time, he notes that there are certain cities which actually behave as spheres. Well, kinds of cities, kinds of like Moscow or New York, you know, or Tokyo maybe. So they are like their whole separate universe almost, you know. And even though you might kind of go there on the surface, you would never be able to really get to the bottom of it, so to speak, right? So they're in some ultimate sense unknowable. And again, I apologize for being too esoteric here, but well, it is what it is. Now, it's probably time to finish this digression, right? So let's talk about nonlinear systems. So a system is a bunch of elements plus a bunch of connections, right? And well, I wouldn't even be able to give you a definition of a nonlinear system. Probably if I'd thought about it like a couple of months, I would be able to, but I'll just give you a really simple definition, not very strict one, and then I'll give you a couple of examples of what I mean. Like it's really easy to do that in a mathematical sense, just very technically, but that's not what I'm aiming for. So okay, anyway, so my definition, like at least the very rough approximation, would be that a nonlinear system is a system which the behavior of which depends non-trivially on the input. So let me explain here. So we have this concept, roughly speaking, of input versus output. So we have this black box, this sort of meta object that we're dealing with here. We put some signal in it, and we read some signal coming out of it, right? So linear systems respond very, very straightforwardly to the input. Like you give one sort of input, you get one sort of output. Like you increase the input a little bit, the output increases maybe a bit more, or decreases. That depends on what kind of system you have. That's a linear system. But nonlinear system might give you, for example, different outputs with the same input. If let's say you have the same input, like one type of input, you have one type of output, then you give the same type of input, but the output is different. You're saying, like, what the hell? Well, that's what nonlinear systems is all about. So this is what I mean when I'm saying non-trivially depends on input, right? And let me give you a couple of examples. So one example would be a laser. In usual optics, you might say, and I have no idea why I'm taking this particular example. It's not that it's very easy to understand. I don't know, I just didn't have anything else on my mind. So in regular optics, things like dielectric permittivity and magnetic permeability and like all those optical, like index of refraction, things like that, which basically is dielectric permittivity and magnetic permeability. So those kinds of things, they are linear in the sense that they are constant. In regular optics, well, a glass has a constant index of refraction regardless of what the hell you're doing with the glass, right? This is the idea of linear optics, not in a very strict sense, but if you have a very strong laser beam, so that's a lot of optical energy, then this assumption that we have a linear medium, such as air even, is not quite true, you know. So the response of air to a strong light beam is different from its response to a weak light beam, right? And in a strong light beam, what might happen is if you have a beam of laser where, and it usually happens that way actually, that in the center you have at least a little bit stronger intensity of light, and at the edges you have at least a little bit weaker intensity of light. So that's a little bit less of electromagnetic energy. What happens is if your refractory index, the index of refraction of air, depends at least a little bit on the strength, on the intensity of light, you have a higher index of refraction in the middle where the intensity is higher, and lower at the edges where intensity is lower. So what happens is you almost have a laser beam itself behaving as a lens, or rather it's forcing the air to behave as a lens. So what happens is, since the intensity, so refraction, the index of refraction is higher in the middle and lower at the edges, it behaves like a lens, you know, this sort of, where you have a thick piece of glass in the center and thinner at the edges. So what it does, it focuses the beam. So the beam forces the air to focus the beam itself. So that's, again, this sort of, it's called autofocusing or self-focusing. I'm not sure what's the proper English nomenclature for this, but this is a like typical nonlinear effect, right? And it happens in laser physics and perhaps in some other places. So we have in linear optics, the response of the, let's say, the air doesn't depend on what kind of signal you're passing through it. But in nonlinear optics, the properties of air itself depend on what kind of beam you're sending through it, right? So you have this non-trivial feedback between the signal you're putting in and whatever the heck you're getting out of it, right? So well, in this case, obviously you might say air is a medium, so it's more like a nonlinear medium rather than nonlinear system. But overall, we're perceiving the laser beam as the input and as the output, and the air in between as a system, right? So that's 3 elements or something like that. Okay, and well, you might probably think about some other examples, but I'm looking at the time, and man, like I was I was planning to talk about that in like 5 minutes, but it's more like 15 minutes already. All right, so yeah, well, you might probably invent some other examples like that. Like if you have a spring, let's say, in a linear case, a spring's response to a whatever mass you're attaching to it would be, well, it would depend only on the length that the spring has increased to. Whereas if it's nonlinear, you might say, well, if the length increases too much, or at least beyond certain boundary, it sort of relaxes a little bit and wouldn't give you as much strength per extra unit length, you know, or something like that. Or if you contract it, it's gonna be tougher, so to speak, so it would resist more than it would otherwise, etc. But again, or you might think about pendulums, like, you know, what they call mathematical pendulum is, oh damn, no, I probably wouldn't be talking about that. Let me just mention that if you have a pendulum to which you attach another pendulum and another pendulum to it, because why not, and then you make this whole thing move, then you have, well, basically chaos. I don't know why I mentioned it, but chaos is also a typical property of nonlinear systems. Like in certain nonlinear systems, you can have chaos. And what chaos is, it's essentially, well, there are at least a couple of definitions, maybe more than a couple, but the one that I do remember easily is that you vary the initial parameters a little bit, and you vary the input, right, a little bit, and your output varies like exponentially large. So a very small change in initial parameters leads to incredible jumps in the output. So that's what chaos is. Because, well, okay, let's just forget about it for now. So in some sense, chaos is like the ultimate nonlinear response. But okay, so yeah, so probably why I talked about lasers. Well, there are several reasons, but one of the reasons is that I myself worked with nonlinear optics when I was doing my bachelor's degree thesis and master's degree was about particle physics. But when I was doing my bachelor's degree, I was studying like responses of crystals to like strong beams of light, like when the optical properties of a crystal depend on the kind of beam of light you're sending through it. And there are many interesting properties in this case, like you might take many layers of different crystals, like let's say you have 2 types of crystals and you stack them into this sort of grid. So you have layer A, layer B, then layer A, layer B, etc. And you have this large stack, and it behaves completely differently with respect to just layer A and B even. Not even talking about just layer A, just layer B. And each one of those layers might respond non-linearly, so their refractive index, like dielectric permittivity, magnetic permeability, etc., might depend in a very complex manner on the properties of the beam you're sending, like its polarization, its intensity, its blah blah blah. So it's a very interesting area of research, and all kinds of interesting nonlinear phenomena occur there, such as bistability, for example, or even multi-stability. So what is bistability? It's when you have 2 different possible states of output with one input. So you have one input and you're not sure what kind of output you get, this output or that one. And that would depend on what the hell the system is all about, this black box in the middle, right? Okay, and multi-stability is when you have one input and you don't know what's in a black box, but you might have different outputs, like many, theoretically infinitely many. And that's like the ultimate nonlinearity again. All right. Yeah, well, one of the problems of studying those kinds of systems is that most of the time we cannot solve analytically all the equations that are involved. We cannot really figure out what the hell is going on, right? So even if we can derive some integral equation, let's say, still we cannot solve it, and that's a big problem. Like sometimes we can do that numerically, and actually I'd say most of the time, but there is certain limitations even to that, like there are divergences, etc., etc. So it's not always helpful, let's say. It's not always possible to get a meaningful result, even though you know how to express this result. You just cannot do anything else, you know. So it becomes like a trivial statement, what you found. So other examples would be Einstein's equations, where again, well, I would say Hilbert's equations. Well, sometimes they're called Einstein-Hilbert or Hilbert-Einstein. That one I would prefer more, probably. So the equations of general relativity, right, where you have on one side the metric of space-time, and on the other side you have what is called the energy-momentum tensor of matter. So you have, roughly speaking, space-time on one side of the equation and matter on the other side of the equation. And it's nonlinear in the sense that you change matter a little bit and your space-time changes. So you change space-time a little bit and your matter changes. So you have to sort of adjust these two simultaneously to get a meaningful result where they would be equal to each other, right, to solve the equation. So that's the problem with solving Einstein-Hilbert, Hilbert-Einstein's equations, is that you have to take into account this nonlinear response of, let's say, again, returning to that other example, you have to get a certain configuration of laser beam as your output, but your medium, let's say the air, responds to the input in a certain manner. So you would have to take into account both the input plus the response of the medium, right? So that's roughly what we're talking about here, to get the appropriate output, I mean. All right, so probably enough said about that. Well, one other example, which would be relatively easy to understand, I think, would be, well, okay, let me just, well, no, let's just focus on the example. So footprints on the sand, a good example, I believe. So let's say, again, you have some elastic thing, like some surface, like a rubber sheet or something like that. So you like put some pressure on it, and then you take your finger away and it sort of restores to its initial form, right? That's a linear system because its state is completely determined by your input, right? The force, the pressure, whatever. So the force is there, then it deforms. Then the force is not there, it's flat again, right? But there are systems, so that's a linear system. But if you take an example of sand, let's say, so you step on it, so the pressure is applied, it's pressed down, but then you remove your foot, and the footprint is there. Like, it doesn't relax to a equilibrium state, so to speak. That's a nonlinear response because, well, there's no input anymore, but the state of the system changed. There is this footprint, right? So, yeah. And so that's the difference between linear and nonlinear systems, at least in one respect, right? So in some sense, you might say, and actually that would be a really good statement, that nonlinear systems might have a memory because, well, how are you gonna record any memory in this rubber sheet? You're just gonna press on it, and then it wouldn't remember you pressing on it because it would restore to its initial state, right? But if you press the sand, it remembers you, so to speak. You walk away, but your footprint is still there. So that's a nonlinear system already. And again, it might store memory because it remembers previous inputs. So the next input would produce a different response, right? Because there was this previous input already. So yeah, basically what I'm saying is that memory is a consequence of nonlinearity. And even those types of memories that we use practically today, like this magnetic disks or flash memory, well, they're also based on nonlinear systems. Like magnetic memory is based on hysteresis. Well, I mean hard disks and things like that, magnetic disks. So what happens is that like certain segments of this magnetic disk becomes magnetized, and they sort of remember this magnetization, right? They don't relax, at least immediately. Like they might relax in certain decades or hundreds of years, but they don't do that right now. And so you might read this footprint afterwards. And hysteresis is this loop which really shows you magnetic hysteresis. You might Google that. So it shows you the response of a magnet to the external magnetic field. And it just rises up as you, like, let's say x-axis is the external magnetic field and y-axis is the magnetic field of your medium you're working with. So you increase the external magnetic field, so the magnetization of the medium rises. But then if you decide to decrease external magnetic field, it doesn't go to zero like immediately. You have to decrease the external magnetic field much more to get the resulting field to zero. Actually probably confuse the axes, but anyway, so, and then you would have to, well okay, it's a really long story. So, and So this sort of system is nonlinear, basically. That's my point. And it has a memory, and it like the output, the magnetization of the medium depends on the external magnetic field in a non-trivial manner. Because, well, again, you have to increase your field to the maximum and then decrease it much more than zero, like to the negative, to demagnetize the medium, right? And then you have to increase it much more than to the zero to remagnetize it, you know? So there is a certain inertia in some sense. The system remembers what the hell you've done with it previously. Okay, and the same stories with flash memory, but it's more like these floating gate transistors, well, capacitors essentially, not quite like capacitors, like a hybrid of a transistor and a capacitor, something like that. All right, and damn, that's getting really long. So one other thing I wanted to talk about is well, it's just a simple idea that really the perception of time is possible due to this nonlinearity, due to the availability of memory. So because, well, let's say you're a linear system, you're this rubber sheet. Well, you don't have any idea about the time because, well, let's say right now you're being pressed at, so you bend downwards, but then the pressure releases and you're flat again. So how are you gonna remember that any sort of pressure was even applied? Like, how are you gonna distinguish your state right now versus back then? Well, like, immediately you might distinguish it if you have some external control loop, let's say, or whatever. But my point is that, well, let's say we have one moment in time and we have one sort of input. Then we have another moment in time and we have another, like the same input, but something about us changed because we're nonlinear. So even the same input, given the same input, we have still the other output. So we can distinguish those two outputs even with the same input. I hope that's more or less clear. So this inherent nonlinearity of, let's say, human beings, and that sounds kind of crappy, but in some vague, super vague, rough technical sense, that's how I mean it, we are able to perceive time because even given the same input, we can give a different output. And that's what helps us to distinguish between two moments in time. And that's what, well, ultimately allows us to perceive time, right? As sort of like a separate entity. Because, well, we perceive same things everywhere. So something else changes, right? Well, that's time. The time flows, right? Well, that's the idea, at least, how this perception appears. Even though you might say, well, it's a vicious circle because, well, the whole idea of, let's say, input-output, this whole machinery, it's all dependent on time in the first place or something to that effect. And that's actually correct. Like I'm not even implying I'm giving any sort of strict definitions here. I'm just trying to connect various ideas together, right? So those ideas actually have the same root, you might say, the idea about nonlinearity, all those chaotic responses and things like that, and the memory and the time. So they belong to the same root, whatever the hell it is. It's just some fundamental human perception, basically, that drives all those. All right. And other phenomena are, of course, also connected to that. Things like feelings, even. Like, what are your feelings? Well, they are what you perceive, that's the input, plus your own nonlinear black box, all kinds of responses, and again, in a very vague sense, that your system have had previously. So all those footprints, they are left in your system. You cannot get rid of them. Well, again, the whole idea of training, it's about leaving imprints. It's about having memory. So your feelings also do train. Like, it's the whole idea of education, of a child orienting in the world. It's gathering those responses and building yourself up into something more complex, right? So your feelings, you might say, well, I just feel something about this object. But you don't just feel. You have all this train of previous experiences which, along with the input, determine what you feel. So it's not the input alone. You're not a blank slate. You have experience and memory, even though you might not be aware of it, but it impacts your perception and your feelings, which is really just a part of perception, quite a bit. Well, that's my point. And you might even generalize. So in some sense, your past influences your present and your future, right? And you might even generalize that to a more like macro level. You might say, well, your whole body, it's not only your previous experiences that determine your current experiences, including your feelings and other reactions, but also experiences of all the other generations that produced you, all those millions or billions or trillions of living beings, or even like quadrillions or quintillions or whatever. Because this genetic code that makes up what you call you, it actually is an archive of all those perceptions and experiences, right? So yeah, like the idea about the blank slate is a really bad idea. It doesn't hold any water at all. But, well, again, it's this nature versus nurture debate. But what I'm saying is that nature plays quite a bit of a role, even if in your everyday experience. So yeah. But of course, nurture is also like at the very least, it acts as a catalyst, right? To release all your previous memories and memories of all the previous generations, which are encoded in your body, and perhaps your soul, if you're feeling more esoteric or whatever. Okay. So yeah, one other interesting thing I wanted to mention is art, like our culture, because, well, people have been fascinated, obviously, with this idea of time and how do you play with time, especially like playwrights and people who work with stories. I like stories, right? So people have been playing with this idea of prophecies, especially because, well, prophecy is really a whole other breed of nonlinearity. It's basically, well, roughly speaking, we perceive history as linear, so we put one input in this point and we get a certain output in the next moment in time, right? But some people have figured it out. Well, what if we have an input from the future? Wouldn't that be interesting? So they've played with it, with the idea of a prophecy. And there's a whole bunch of myths about it, obviously, and legends and funny stories and very sad stories. Like, again, Oedipus Rex, the story which was put in stone, or how do you say it, by Sophocles. So this idea that you get a prophecy from the future, well, like, you get a glimpse of what's future gonna look like, and you change your behavior. So that's like a nonlinearity on a whole other level. Like, it's not just the input that influences the system. It's like the output also influences the system. It's like a feedback loop. What you do today produces the future. You get a glimpse of this future, and it impacts your behavior, so you change it, and etc. So it's like the feedback loop appears. But of course, the whole drama about Oedipus, for example, is that, and by the way, feedback loop is also inherently a nonlinear phenomenon. Like if you're talking about the amplifiers, where you have the most of the time negative feedback, well, for various reasons. Like if you have any idea about the radio technology, like the electronics and etc. Or amplifiers of other sort, which give you a positive feedback to will literally amplify the signal. But okay, so yeah, basically a prophecy is this sort of feedback loop, just as you have in an amplifier, where you take a part of the output signal and put it back in, so you get this feedback loop. And well, another story, kind of like Oedipus. Yeah, so the funniest thing is about it, what's maybe even the saddest thing, is that he acts receiving this prophecy, or rather his parents firstly act through receiving this prophecy as to actually help it to become true, right? So it's this self-fulfilling prophecy. So it's sort of, you might call it, you might say it's a negative feedback loop, right? It sort of stabilizes your signal at a certain level. And the same stories with Anakin. See my video about Star Wars, Darth Vader, I mean. So he also received the prophecy, and the fact that he received the prophecy fulfilled the prophecy, because it wouldn't be fulfilled without it. Right. So there was this famous Thomas theorem in sociology, which basically states, Thomas was a sociologist, American sociologist in second half of 19th century and first half of 20th century. So basically, Thomas' theorem states that if people believe that something is true, then they act in such a way that the consequences are such that as if it was really true, you know. So if you, let's say, you believe that a demon orders you, well, it's my own example, just off the top of my head. So if you believe a demon ordered you to kill people, and you're going to kill people, and you killed a bunch of people, well, like, it's almost as if this demon was really ordering you to kill these people. I mean, the result is literally such: you've killed a bunch of people, as if the demon existed. I mean, so yeah, it's sort of this self-fulfilling prophecy. Like, your perception really shapes what you're doing, what you're focusing on, what you perceive, how you feel about all that, etc., etc. So it's a really serious thing. I mean, of course, it has all this stupid aura of this despicable self-help, new age kind of crap, but just mechanistically it works, right? If you have a certain perception, it sort of plays itself out through you, right? So it's almost as a separate entity, almost like a god, you know, if you know what I mean. Yeah, why was I telling about the demon? I could have said, well, if you believe that a god orders you to be kind to people, and you're kind to people, it's almost as if God existed, right? That's a good example also. Okay, yeah, so, yeah, well, I've already talked about this nonlinear response between the past and the future and the feedback. Yeah. Well, to sort of conclude this rant, I don't even know what to say, like I've already ranted enough. Like, one other thing probably that we might talk about really briefly is this, well, the whole idea of time. It's really only through the realization of that something changes without you. So your medium, roughly speaking, depends on something else other than you. That's what drives at least a significant fraction of your behavior. Like, if you're, let's say, well, that's what Jordan Peterson called the discovery of the future, for example. Even though he really didn't emphasize it as such, but he certainly talked about that. Like, if you think, well, okay, today I feel pretty well, but what's going to happen tomorrow? I'll probably feel hungry or maybe cold or something like that. So maybe I should do something about it today. So that's roughly what this, again, sort of this feedback means. So you're sort of helping yourself in the future, because you yourself in the future, you sort of model the situation of being in the future and kind of feeling regret about not having more food, sort of. So it's you from the future giving a prophecy to yourself that, you know, guy, I'm gonna feel hungry. Maybe you're gonna, you know, help me somehow. So maybe you'll go and get some more food, right? Or something to that effect. So it hopefully you can see how this human behavior and time and this inherent nonlinearity of both plays out, and I really think it's important. But that's only one aspect. That's the future, right? Future existing even before it existed, so to speak, so that we can really perceive the whole fabric of time, so to speak. But even the past can influence us, of course. I've already talked about the feelings, the DNA, the whole experience, the memory, blah, blah, blah. And by the way, memory also can change. Like it's a known effect that the more you address your memory, the sort of more warped it becomes. And it's obviously true for any physical carrier of memory. Like you read a book, you give a book to 1,000 people and it would look really unreadable afterwards. Or, I mean, your magnetic disks or flash memory, they're also get damaged, etc., and unreadable, blah, blah, blah. So the same thing happens with the human memory. Like the more you address your particular memory, the more it is sort of polished to some very, very rough depiction, and even idealized and even sort of mythologicalized depiction of the events. So you're trying to archive it, to simplify it, and by doing that you're kind of cutting off many other parts of it. So really, and it's a known effect that the more often you address certain memory, the more sort of round, spherical, returning to my digression with meta objects, it becomes. So more impenetrable and more sort of, I don't know, like a fancy kind of thing where only the surface is penetrable, right? The surface can be seen. Okay, so yeah, probably one last thing I wanted to mention with regards to that is the documents, the historical documents, because they represent a memory of their own, right? But they're also nonlinear. Again, if you think about it, like a naive point of view would say, well, okay, we have like a linear flow of time, which again only appeared, or at least supposedly, with Christianity, you know, Abrahamic religions, etc., because pre-Christian or non-Christian societies, they actually had like a cyclical notion of time. So this whole concept, oh, by the way, I didn't even talk about the entropy, damn, but entropy is also connected to the arrow of time, obviously. And it's such a trivial notion, but some people like put it forward as almost some sort of discovery. And gravity might also be connected to both the entropy and the arrow of time. Again, see Verlinde's emergent gravity. Well, the idea is very simple, really. It's like gravity only attracts and the time only runs forward. So maybe there is connection. Well, maybe there is. Who knows? Okay. Which again is not proven. Like you might say, well, let's introduce a different gravitational potential where it would, let's say, repel at short distances or something like that. Damn, what was I talking about? But historical documents, right? So you might have a naive vision where you would have just the progression of events which are reported to us linearly, like we perceive the signal as it was, so to speak, right? So when you're reading a book from 1514, you really think it's a book from 1514 because why not? It's this signal that we're catching from some time in the future. But there were people, and as far as I'm aware, I'm not sure this is the case, but this is the first. Oh, I'm not sure actually. Well, Velikovsky was one of those people who actually suggested that there might be nonlinearity even in this historical signal. But there was definitely another guy, Morozov, this Russian terrorist who participated in the murder of Tsar Alexander II. He was one of those British spies who, well, basically were working for demolishing the Russian monarchy and who succeeded in 1917. So he was one of those, he was basically the father of this new chronology, right? So he also had this idea that, well, you know what, and what if this signal gets disrupted along the way? Let's say, what if what you perceive as a source from 1517 is actually a source from 1858, let's say. So it was sort of produced here, and it's also some sort of wicked refraction that makes it look like it came from here, you know, sort of. So this nonlinearity of historical documents, that they might be fudged, they might be lost, they might be remade, they might be blah blah blah. So it's a big discovery, I would say, in historical science or whatever. Again, I would say history is not science. In my video about stories of history, I've claimed that history is really an art of reconstruction rather than a science or philosophy or something like that. Oh, damn. But okay, well, hopefully it can be seen that, yeah. Well, basically, when I'm saying that historical documents are nonlinear, what I really mean is that, well, firstly, like, you can't really rely on them in some sense. And yeah, well, I've probably talked too much about it, but since we are here and talking about history, I'll probably just mention that my approach to history is very simple. You just go from the present moment backwards, and you do it, the slower, the farther you go. And in that way, at least you have some hope of tracing those interventions along the way, or some anomalies, or some, you know, this chaotic responses or something like that, mechanistically speaking again. And if you're gonna do that, you would pretty quickly arrive at the conclusion that history actually stops at some time in like 1600. Like afterwards, it's like fantasy. It's like John Ronald Reuel Tolkien, or whatever the heck the pronunciation of his name is, because there's just too many anomalies. Like it's just pure chaos. Like we could have been on these trajectories from anywhere else, you know. And I'm pretty serious about that. Like, yeah. But okay, I really ranted enough, and it's sort of like a bad place to end. Maybe there's something good, some good, you know, lesson that we can learn from this. I don't know. Like, really what I've talked about is that nonlinear system is a system which the behavior of which depends non-trivially on the input. Like, let's say you have the same input twice, but you get a different output. Well, it's a pretty good sign that you have a nonlinear system. And I've gave you a couple of examples, like these lasers. Like you have the same air and you put different laser beams through it with a different intensity, and the air behaves differently. So let's say a higher intensity laser beam would be focused quite strongly, whereas a lower intensity beam would be either weakly focused or not focused at all, etc. So even though the system is sort of the same, this black box of air gives you a different response. All right, just because of all those non-linearities. And the other point I made, which is probably a little bit important, is that memory is a property of nonlinear systems. Again, the systems that can give you different type of output, even with the same type of input. And I gave you examples with magnetic memory, flash memory, etc., etc. And I've said that probably the perception of time in the first place is due to some sort of nonlinearity, again, in sort of reductive type of sense, in mechanistic type of interpretation of a human being as a system, again. Even though, again, as I've mentioned in my video about the stories of medicine, you might perceive a human being as a medium, like let's say a medium for symbiotic organisms, or well, like a blood, it's obviously more of a medium rather than a system, etc., etc. Or you might even perceive a human being as a sphere, as something unknowable, all right? Again, returning to this classification of meta-objects by Peris Legan. Oh, damn. Probably should stop somewhere here. Yeah, be like a sphere, you know? It's probably the best lesson we can learn from here. Thank you for watching. The eons are closing.